most of the attendees are here, so just give it a couple of minutes. Okay, I see the people slowly coming in. For everyone who just joined, good afternoon. I think we have quite a few more people joining, so I will give it a minute or two more, and then we'll get started. Okay, I will already start off with an introduction before we deep dive into the technical part. Thanks everyone already for joining us so far. I think we have a few more people coming in, but we already start before we lose more precious time. Before we start, I will give a quick introduction. Most of you know Tergos already. For the ones who doesn't, Tergos is an IT recruitment company where we mediate specialists who work in the IT infrastructure. Over the years, we have gained great partnerships. One of them is with Cloud Nation. So today we have Mark Norman joining us. He's a cloud networking competence lead, if I say it correctly, at Cloud Nation. He will talk to you more about multi-cloud networking, challenges and evolution. There will be a moment during the webinar, but also afterwards to ask questions. So please feel free to do so and yeah, enjoy. Mark, the floor is yours.
Well, thank you, Kelly, and also thanks for inviting me for this session. Yeah, let me try sharing my screen. Are you seeing it now?
Yes, we are.
Excellent. All right. Well, welcome everyone. My name is Mark Norman. I'm a solution architect at Cloud Nation. And well, I'd like to talk to you a bit about cloud networking today and some topics that I've encountered for the last few years and some trends I see and things that I think might be interesting for a larger audience. If you have questions, I'd love to answer them, but please put them in the chat. And I'll have a couple of breaks during the presentation when I will see what's come in and answer them as well as I can. A little bit about me, my background. I've been working in IT since 1998. Quite a long period of that was dedicated networking, traditional data center on-premise networking. From 2009 onwards, got a bit more broad and diverse roles. And since 2017, I started focusing on public cloud. And besides my work, I love fishing and martial arts. I joined Cloud Nation at the end of 2018. That's when the company was founded. We only focus on public cloud, and we're located in Bunnik, near Utrecht. Yeah, and we're growing quite rapidly. I'm happy to say it's been quite a success so far. I believe we're approaching employee number 45 soon. So yeah, it's going really well. A bit about our company and our vision. We do cloud architecture and engineering consultancy. That's our generic competence and expertise. But besides that, we've also defined some specialties that we saw were quite necessary for our customers. One was cloud security, migration services. And networking connectivity is one of those, and that's the topic I've been focusing on mainly. And well, besides that, those competences, we are also offering managed cloud services to our customers. We have a landing zone as a service, which we've been deploying successfully for a lot of our customers who don't have a public cloud footprint, or they started but they got stuck on some point and really needed help to improve their cloud deployment. So we have a landing zone as a service that we deploy for them, and one of those things is also managed cloud networking. We strongly believe in a strong ecosystem. Yeah, we work together with a lot of parties. Of course, the large public cloud providers, but also some technology and security partners and sourcing and billing partners like Tergos and some other solution partners. And this is growing and evolving every month. So it's and we really see that we and with our partners we strengthen each other. Customers are it's not often that you are the only one that can help them. You often need help from some kind of expertise that you don't have yourself. So we really see this as a major contribution to our success. Well, let's talk a bit about networking then. I think quite a few of you are familiar with the traditional IT and traditional data center networking. So diagrams like these must be quite familiar. We have access switches or top of rack switches. In between there, you have the aggregation or distribution layer. And there's a core, some core network layer. And it's all interconnected, highly redundant, high available, etc. But this is no longer valid when you go to the cloud. This completely changes. Within traditional data center networking, you have a lot of components, and you can customize those components in the configuration. You can tweak it, adjust it, so it does exactly what you want. You have quite stable environments. Of course, you have changes, additional VLANs, or some additional components, but not a lot will change within that distribution or core layer. And you have central change management. However, you do have a lot of components to manage, and what quite a lot of companies have seen in the last few years is that network provisioning, network adjustment is just not able to keep up with the pace of application and workload development. So that's one of the key drivers why a lot of companies move to public cloud. When you go to public cloud, the center of gravity changes. When you look at the traditional data center network, yeah, it's a complete paradigm shift, and I'll dive a lot deeper into those components in the slides. But the deployment and the configuration is so different from traditional networking, but still networking is very vital, a very vital component for your workloads. So what changes then? Instead of managing components and having access to a physical data center and being able to connect cables and wires, instead of that, you start using pipelines. Your infrastructure and also your network transforms into code, and the pipeline takes care of the checks, the validation, and the deployment within your public cloud provider. What are some of the most important differences? You're not able to buy or install boxes. You don't have to install cables. Your infrastructure is nothing else but code, and you can deploy them or destroy them when needed. For example, if you need to run a proof of value or want to do some experimenting, you can spin up an environment, make a copy of an existing environment, run your testing, and destroy it again, included the networking components. And you can do this all over the world. The major cloud providers are present in all sorts of regions all over the world. So wherever you need to be closest to your customers, for example, you can deploy your services. And this cloud service provider takes care of all the stuff you had to do yourself in the past, the maintenance, repairing switches or routers, and the availability and redundancy, all those things. And yeah, a lot of these services are available as a managed service, so the cloud service provider takes care of them and make sure they're patched, they're up to date, they're available, they're running smoothly, all those things. And when you want to apply additional redundancy, you just implement your service over additional availability zones or even different regions. That's a topic I'll focus on in the next slides as well. Your workloads, your applications, and your databases are much less static than we were used to having in a data center. And like I said, they are created or destroyed when necessary. You don't have to do any investment up front. You just pay what you consume when you go to public cloud, and that also goes for the network. So if you don't need any subnet or any virtual private cloud anymore, you just delete it. You still have the code, the scripts and the templates you use to deploy it. So if you need it again, you just deploy the script again, and it's available. There's no need in keeping it operational or running, and probably costing money as well. However, public cloud network services are great. There are also some limitations. Like, for example, in this case, Azure for Microsoft and AWS have a managed IPsec VPN service for site-to-site connections. It's great, it's robust. However, they are limited to 1.25 gig per tunnel. It will be sufficient for most companies, but let's say you're doing a large database migration, you might quite easily run into this limitation. So it's something to be aware of. Another great network service from AWS is Private Link. It's a service provider, service consumer model. So let's say this VPC here in the middle is the service provider, and the virtual private clouds on the left are service consumers, customers of the VPC in the middle. They can access that VPC service through AWS Private Link. And Private Link also enables you to have an on-premise or data center server as the application source. So your customers can access that service from within AWS. You can still provide your on-premise services this way. However, you can only use a private IP address. It's not allowed to use a public IP address. So again, a limitation that if you're not aware of it, you can run into problems or delay. And there are some more. I believe Azure has announced a premium Azure firewall, which is a next generation firewall, higher than level 4, the normal stateful firewall, but at least in AWS it's not available yet. So if you want to deploy it, you have to do it yourself. You have to install it on a virtual machine or EC2 instance, like it's called in AWS. And there's no native managed firewall available, which will automatically scale or be updated by and managed by AWS. You have to deploy and manage that yourself. And let's take a look at Virtual One from Azure. Also a really nice new networking service from Microsoft. With this, you have a virtual hub. That's like it said, it's a hub. It interconnects everything. You can attach all of those Microsoft Azure services to it, but you can deploy anything else, any custom service in it. So that's also a limitation. For example, Azure will offer you the next generation firewall, but you will also want to add some advanced load balancing to the hub, for example. That's simply not possible. You can only deploy the services that Azure defined for that. Overlapping ISP space, something that network engineers will really recognize. You need to configure NAT translation, often the case for IPsec VPN tunnels. The native services from the cloud providers don't have any solution for that. You cannot configure source or destination NAT as you want. And there are also a lot of hard limits on the numbers of VPC peerings or VNet peerings or the number of specific gateways you can deploy per region. So you also need to be aware as your environment grows, what are my limitations? Sometimes you'll just hit one of those limitations and you cannot expand further. And you'll have to find a different solution. Looking at Direct Connect, for example, that's the private high bandwidth, low latency connectivity solution from AWS to connect your on-premise location to the AWS environment that you deployed. There's a limitation on the number of CIDR agents you can announce. So let's assume, I'm not sure if it's 20 CIDR ranges, but maybe it could be 100 now. But let's say you have a cloud environment that's growing rapidly with a lot of VPCs. Business units deploying new virtual private clouds all the time. You could easily hit that limitation from the BGP broadcast. And one thing that's related, this is an express route example. That's the comparable solution to Direct Connect from AWS, but then for Azure, there's no route summarization. Let's say all those VNets or VPCs you have in the cloud are using all sorts of IP ranges from within one large subnet. The Azure Edge router will not summarize those routes into one route that's being advertised to your on-premise router. Now it will just announce all the individual routes. So your route table can become quite large, especially when your cloud environment grows. There's not just limitations for each of those public cloud solutions. There's also quite a few differences between them. It's not that, Azure is private cloud, public cloud, Google is private cloud. So most of those concepts must be the same. They're similar, but they're definitely not the same. That's not only for database or virtual machine solutions or other artificial intelligence, for example, but definitely also for network solutions. Looking at Direct Connect again, I mentioned earlier, it's the private connectivity solution from AWS to connect your data center or your main office location to AWS. When you order a connection, you just get one physical connection. But if you do the same for Azure, you order one express route circuit, you get two physical connections that are a redundant pair. So you get a primary and a secondary connection. So if one of those fails, let's say the primary fails, the secondary will take over. So there's already redundancy built in. So if you're not aware of that, let's say you are in Azure and you want to you have that redundancy built in, and you assume you will get the same for your AWS connectivity. That can be quite a costly mistake. Looking at Google Cloud, they also have the concept of the virtual private cloud. And within Google, it's a worldwide, global construct. So you just create one VPC. That's their vision. You just need one VPC, and within that VPC, you deploy everything, all the regions you need, and all the subnets in the different locations. But looking at AWS and Azure, they have a different philosophy. Although the term is the same, it's a virtual private cloud in AWS, and also the VNet in Azure. It's a regional construct, so it cannot expand multiple regions. You can interconnect them, of course, but that's quite a major difference between the two. Although they, from the name, they might seem similar. Looking at some security network services. On the left, we see here an Azure solution with a network security group. It's in fact, yeah, you can call it a firewall. You can define which source and destination IPs and port numbers are allowed, and the rest will be blocked. And within Azure, you just have one concept, that's the network security group, and you can attach that to a subnet with virtual machines, or you can attach it to a network interface from an individual virtual machine. So you can make a granular solution. And looking at the right here in AWS, that will consist of two constructs. One is the network access control list, which is a stateless IP filtering solution. So you need to, if you want to allow traffic, you need to allow it both incoming and outgoing, and it's stateless. That's always connected to the subnet. And if you want to do filtering on the virtual machine or the instance level, then you have to use a security group. It's a completely different service, and that is stateful. So for security group, you only need to define which kind of traffic you want to allow. And that will arrange the return traffic automatically. So let me quickly have a look. Were there any questions incoming?
There are no questions incoming yet, so if anyone has questions now.
Okay, well, let me continue then. Let's see. Oh yeah, you can see my screen again, right?
Yeah, we can.
Okay. Well, like I said, we've seen a lot of customers all over the world moving to public cloud, and as companies, it's not only a lot of existing companies moving to the public cloud. There's a lot of new companies that have come up in the last couple of years that have only started in public cloud. They don't have any on-premise footprint, but also for existing companies, the more they grow within public cloud, the more the network becomes more and more important as well. What I've seen, especially with larger customers in the Netherlands, is there a trend towards using more and more VPCs or VNets. Traditionally, we would say, well, we have one virtual private cloud, in that we define different subnets, which can be seen as the individual VLANs as a comparison to the traditional data center. But and we see more and more customers deploying individual VPCs or VNets for departments, but also sometimes for individual workloads. A VPC or a VNet, it doesn't cost anything. It's just a logical separation of other VPCs and VNets. So there's nothing stopping you from deploying more of these. The only thing is that it can become a quite large environment from that point of view. And yeah, it can have a security and a management and also a billing advantage. Security-wise, everything can be separated from a workload level, like an application chain or a specific department, but also privacy sensitive data or really business critical applications can be put together within one VPC, and access strictly prohibited for anyone that doesn't need access to those, but also a billing advantage. It's a good practice within public cloud to make sure that every department or part of the organization gets good real time, or at least a good report on the amount of public cloud costs they have spent for each month. And it's best to even do it real time, but you really want that accurate reporting, so they have insight in what they've burned on the cloud costs every month. And one of the advantages of public cloud is you don't have to invest anything. There's no payment up front, but the downside is it's really easy to spin up additional resources, and that is something you will see on your monthly bill. So to make those costs more accountable, to make it clear which department was responsible for spinning up those resources, it's really good to use separate VPCs or VNets. So it's much more easy to get that insight. I'm not sure if everyone's familiar with the concept of subscription or account. It's the environment within which you can deploy your VPCs or your VNet. The account or subscription is the worldwide overarching concept within which you can deploy your services. So also billing is done on an account or subscription basis. So, but I see with a lot of customers that, especially the larger ones, they're also they're using more and more subscriptions or accounts to get a more fine-grained landscape, not put everything in one really large VPC or VNet. But yeah, the downside is how do companies have to are able to cope with this larger scale. There are some good native scaling solutions. Looking at AWS, a couple of years ago, the Aws Transit Gateway was announced and deployed or implemented. And yeah, the name Transit says it all. It interconnects everything. You get your VPCs from your departments or specific workloads that you can connect to the Transit Gateway. You have your direct connect, which is able to connect to it. IPsec VPN can be attached to it. It's really is the center of all the connectivity. Also, traffic between VPCs, it stays within AWS, but it can all be managed within the Transit Gateway. You don't have to create individual peerings between all those VPCs. As long as they're attached to the Transit Gateway, you can allow traffic between those VPCs. It makes those large environments much more scalable. Oh, something went wrong there. And we're back. Another quite a new feature is the Gateway Load Balancer from AWS. They had a few load balancing solutions already, but this is one specific for companies that have their, like for example, a next generation firewall or advanced load balancing, which they install on a virtual machine or an EC2 instance. The Gateway Load Balancer is a perfect solution to make the best of that those additional gateways within your workload. So if you have, for example, an active firewall setup, then the Gateway Load Balancer is a really good instance to take advantage of those that firewall setup. Mentioned Virtual One already from Microsoft Azure. Just like the AWS Transit Gateway, it sits in the middle and it interconnects everything. All the VNets with your application workloads, your virtual machines, your databases, everything, but also ExpressRoute, your SD-WAN solution, client VPN, it all interconnects to the hub in the middle, and the Virtual One will enable connectivity from one of those locations to any other location. And this really adds to the scalability of your Azure environment. Also, a recent announcement from Azure is the Azure Route Server. Quite a bit similar to the Gateway Load Balancer. It makes managing route tables within your VNet a bit easier if you're using custom firewalls or advanced load balancer, for example. So the cloud providers themselves all are really doing the best to think of and create additional services to cope with that increasing scale within the public clouds. But what happens when you're not just present in one public cloud? Let's assume you have to cope with multiple public clouds. Azure and AWS is a situation I come across a lot in the Netherlands, and Gartner also confirms that a lot of those customers said they are already working with two providers, or at least thinking about it. So this is a reality that's increasing every day at the moment. So let's dive a bit deeper into some real cloud networking. I'd like to talk a bit about Aviatrix. It's a company that was founded in 2014. The founder already saw back then that cloud networking was good, but it certainly had its limitations, then even more than now. But they've grown quite hard in the last couple of years. It founded in 2014. They were born in the cloud. They only do cloud networking, no on-premise networking at all. So they know, they are familiar. The only way they know how to do networking is the cloud way. And they do fix and improve and offer a lot of additional services on top of the native services that I've mentioned in the previous few slides. And they received a lot of funding, and they're growing really rapidly, and they're also developing use cases and functions within their platform in a really high pace. So every month there are new use cases to be used with their platform. Let's start with a bit more an architectural higher overview. If you look at a cloud environment, you have your applications layer at the top. Those are your VPCs, your VNets within the public cloud. That's where your applications are. That's where your data are. That's where the processing and all the intelligence happens. Looking at the bottom, the cloud access layer, there are a lot of different connectivity options for your customers or your partners or your employees to connect to those workloads. You have your branch offices, your partners who need to connect to VPN, for example. And there's also the internet, of course, for public websites, for example. And what they define together with a few of their large customers is a global transit layer in between the application and the cloud access layer. And that transit layer is what they can really offer, and what interconnects those other two layers, and it enhances a lot of those features. And over all those layers, you of course have cloud operations and cloud security, and that's something they can really help with as well. Oh, I'm doing it again. Yeah. Well, how does it work? How do you use or start using the Aviatrix platform? You start with one controller. It's a software image that you deploy on a virtual machine. It can be in any public cloud you want. And that's really is the control plane and the brain of your entire cloud network. Through that controller, you can deploy Aviatrix gateways, which are software routers, but quite intelligent software routers. And you can deploy those both in the transit layer, but also in the workload VPCs. But those gateways and the controller also really integrate well with the native constructs, the VPC, the route tables, all the stuff I mentioned earlier from the cloud native services. And they also have really good integrations with next generation firewalls, like for example the things you see here, the brands, the major brands, and yeah, you still see the controller as the central component, and it's all deployed through Terraform. It's only yeah, you have just one single multi-cloud provider. It doesn't matter if you use a single cloud or a multi-cloud. You just have one Terraform script, and through that Terraform script you talk to the controller, and that the controller will take care of all the deployments and the configurations, and no matter how large your environment is or in which public cloud it will be. And those gateways, they are taking over the routing within your cloud environment, and because they take over that routing, they collect a lot of information about latency, bandwidth, application flows, and that information is all exported to Copilot. And well, Copilot will give you a lot of insight into yeah, how large your environment is, which regions are which components deployed, and individual application flows, stuff like that. Well, let's see how that will be deployed in a fictitious environment. Let's say we're in AWS with 2 VPCs in one region, but it can be deployed over multiple accounts, and it can be configured as active-active. There's always end-to-end encryption between those gateways, and they will make sure only traffic is sent to gateways that are up, that are running, so they guard that network correctness. Let's say we have to integrate a second region, expand our business, and we can easily extend that transit region. And as the gateways in the middle layer, those are the transit gateways, and attach additional VPCs to that. And then we can copy that similar concept to other clouds, Azure, Google Cloud, Oracle Cloud. Just repeat the same architecture, the same deployment, and all of that still through that single Aviatrix controller. High performance encryption between those transit gateways. And what this will also enable us is to introduce multi-cloud network segmentation. Let's say we have in all these 4 public clouds, we have both test and acceptance and production VPCs. Through the controller, you can define security domains to make sure that only the light blue VPCs or VNets can communicate with each other, and it doesn't matter if they're in different clouds. The gateways will make sure they can communicate with each other, and all the rest of the traffic is blocked. And again, the service insertion, you can insert firewalls on the transit layer to make sure that every traffic that is necessary, that you want to have inspected, is always sent through those next generation firewalls before it's sent to the destination. And on top of this, enterprise operational visibility, the type of visibility the network providers, the cloud providers will not provide you. Well, I'll dive a bit deeper into that in the next slides. And that's that visibility and management and operational excellence that you really want is offered through Copilot. So there's only really 3 main components: the controller, gateways that will take over the routing, and Copilot. That's an optional feature that you can deploy for that additional visibility and troubleshooting. Oh yeah, and one last one, or a couple of last ones, are also additional security features: secure cloud access for your employees, and they can also offer secure ingress and egress. For example, FQDN filtering, if you only want specific URLs to be able to be accessed by your workloads. And all of this is cloud native. It has a full integration. Let's say in your AWS region you want to use an additional AWS Transit Gateway. it can seamlessly be attached to an Aviatrix Transit Gateway, and you can still use that if it's cheaper, or if you don't need encryption. That can be different reasons to still use the native services. Well, let's say you're using Aviatrix within your public cloud, but in this case, this is an example where you only use it in the transit layer. On the left, on top, you have the different VPCs with your regular AWS workloads connected by an AWS Transit Gateway to an Aviatrix Transit VPC that is attached to an Transit VNet within Azure, which has a couple of VNets with similar workloads. And both of those transit layers are connected to an on-prem data center, direct connect on the left and express route on the right, which is exchanging BGP with the data center router. And the most important part is the active mesh peering that interconnects the transit gateways within both public clouds. Well, let's assume you have a failure on your direct connect connection on the left here. The data center router notices that its BGP peer is no longer available, but it also has a second route to the AWS workloads on the left. It knows it has a second route through ExpressRoute. So now you can connect to AWS through ExpressRoute, the Microsoft service. Just send it to the transit VNet. That will make sure the traffic is sent over the active mesh peering, over the cloud backbone networks to AWS, the transit layer, and then arrives at the VPC. Of course, it will probably have a bit higher latency, but you will reach redundancy in a way that's never seen before. At least with the native services, this kind of redundancy is next to impossible. Going back to traditional networking, data center, if there's any network administrators in the call that are responsible for managing a data center network, they know network monitoring is vital for them. They need tools to give them insights, which links are up, how are they performing, how is the bandwidth being used, are there any interfaces that are causing errors, all that kind of stuff. So there's a lot of tooling available, PRTG, SolarWinds, Live System, all based on SNMP or NetFlow, that will give them the insights they need. And especially when you're hosting real-time applications that need any form of human interaction, like video or voice or gaming, for example, the network is vital. You need that insight. You need to know if it's performing correctly or if there's any problem, find out immediately, and also where is the problem. However, the cloud service provider doesn't provide you those insights. Public clouds are great for hosting those real-time workloads. For example, a video or a voice conversation platform. Because those public clouds are present all over the world, you can put that application really close to the end users for low latency access, high availability over multiple availability zones. But those cloud providers will not provide you the insights on how their backbone network is performing or within your VPC. The insight is really basic, just like the diagrams here on the left. Not the stuff you're used to having within a data center. There are some logging options for source destination IP. You can do some troubleshooting, but it's still limited. And when you have some connectivity issues for BGP or IPsec, for example, there's no or at least very limited logging features. If you want to do a packet capture, do some really deep dive into a packet analysis. Where's the application going wrong? There's no out-of-the-box solution you can just start using immediately. You have to prepare that and build it yourself before you can start using it. However, Copilot from Aviatrix does give you what you want to see within public cloud. It automatically builds a topology map for you. You can see through the icons which cloud is it in, which cloud is it running in. If there's a broken link or any trouble, the link will light up red. Capacity usage with all kinds of different parameters. Types of data that are being sent, and also individual flows between endnodes, between IP addresses. You can see what are the big consumers and what kind of protocols and port numbers are those consumers using. Which regions are they in? Could it be that we need to move a couple of systems because interconnectivity will become more efficient then? Those are the types of insights that network engineers were used to having at a data center. That's not offered by the native cloud service providers, but those are the insights that Aviatrix can offer you when you deploy it in your public cloud environment. Using Aviatrix, to summarize, it provides you with that single pane of glass. You have one single controller with which you manage and configure everything. They have powerful troubleshooting tools, and you can manage IPsec VPNs at scale, for example, deploy everything as code, just like we're used to doing in cloud. We do the same for our virtual machines, our applications, etc., but we can do it with the network as well. But still, if you want to keep using a few of those native services for all kinds of reasons, that's still possible within Aviatrix. They have a seamless integration with those, and it doesn't matter if it's in Azure or Google or whatever. They're about to onboard Alibaba as well, I heard. And integration with native next generation firewalls, like the big vendors, Palo Alto, Checkpoint, Fortinet, and also a lot of SD-WAN vendors. Let's see, I believe I saw one question popping up.
There are also more questions in the chat box, Mark.
Let me look at the Q&A. Have you had experience connecting different cloud providers? Think of a case, DR, where provider outage would allow resources to be moved to a different provider. Not sure if the use case for this would be use gateways. Yeah, I definitely have experience connecting different cloud providers. The Aviatrix platform is excellent for that. Yeah, that's really what their main use case is. But moving workloads, that I do, however, feel a bit different about that, because there are so many differences between similar services within those cloud providers. They do have a lot of differences. So it's not that easy to shift workloads from one cloud provider to another. Or yeah, the only use case might be if you have, for example, container-based workloads, which are quite cloud agnostic. But then you would still have your databases or data analytics tooling that would need some adjustment as well. So from a disaster recovery perspective, I don't see a lot of customers using that, but they do interconnect both clouds, and then they use each cloud with it for its own strengths. Like, for example, AWS is really good for application development and building stuff. Azure is more used for data analytics, for example. Google Cloud more for the IoT side of things. So, and when those workloads need interaction, then yeah, the transit interconnection can be a really good solution. With respect to Cloud Nation's customer base, what's the ratio of AWS versus Azure versus GCP? I think our customer base is around 50-50 AWS and Azure. We have one OCI customer, Oracle Cloud, and I believe we had one Google customer, but it was a one-time project, but not a regular customer. So the bulk is AWS and Azure, and those are about the similar size. In your observation, right tool for right job, way of asking similar questions, are there typical use cases for each of the public cloud? Yeah, I think I just mentioned those examples. AWS for building stuff yourself. We see a few smaller customers that build their own backends, their own applications or mobile apps. They use AWS a lot. There are a few customers that are more on the data analytics side that use Azure a lot. So those are the main use cases. Well, still a lot of questions coming through. This is good stuff. But I see I'm quite a bit short on time as well. So hybrid cloud, yeah, we see that a lot. But hybrid cloud is, yeah, of course, that's where ExpressRoute and Direct Connect come into play for connecting an on-premise data center to or an office location to AWS or Azure. I think I'll skip the last few questions and finish my presentation, and we'll see which ones are still present at the end. Let's continue with the one. That's also an important part. For a lot of enterprises, a lot of customers, they do have their workloads migrated to the cloud, but they still have a lot of branch offices, for example. But in my opinion, MPLS, it served us well through the 90s and from 2000 onwards. But I think now it's dead. It will stop rapidly. I see quite a few customers looking at replacing it. Its deployment is too slow. If you need a new connection, it can take up to weeks. It's too expensive compared to newer solutions. Integration with public cloud is complex, and yeah, the usage isn't flexible. You can't rapidly increase bandwidth or connect to a different cloud region, for example. You're bound to long-term contracts. So it just doesn't fit in the cloud era we're in at the moment. So SD-WAN, in my opinion, is the new normal that you would look for in a one solution. There's quite a few providers, established providers. I put a few up here which all have good reputation, but you need to choose a vendor carefully and really look at your own use case and your specific requirements. Not all have their backbone network within your region or even over the world, which will result into then using the internet, which is fine, of course, but don't expect the same low latency as you have in an MPLS if you have that already. Some are still fully box-based with not the virtual firewall integration. And in addition to that, to their own box, for example, you would need to buy an additional box if you want the firewall on a branch office as well. And yeah, they're not all that good into integrating with public cloud. So if you have your workloads running in public cloud, look at an SD-WAN vendor that's also capable of integrating with that. I'd like to mention Ariaka from that perspective, which is also a company we're working with. They are an SD-WAN provider, and they just like Aviatrix, they're doing really well in the market and growing really fast. They do have a global backbone network, which as soon as they reach 50% capacity on any link, they start increasing the capacity of that link. So the chance is very small they will run into any bandwidth limitations. So they're monitoring that quite strictly. You can still use partly MPLS or an IPsec VPN if that's more advantageous or cost effective, for example. They do that integration. They have a SaaS solution, a portal where you can configure really everything. It's also just like cloud, OpEx based. You don't do an upfront investment. They do have that integration with virtual firewalls on their boxes for that security within your branch, and they also have a good cloud native integration. They offer a portal with some real-time insights. Again, you really want that operational monitoring. If branch connectivity is important for your business, you need those insights. You need insights. Is this link available? Is it meeting its SLA? And if not, I want to be able to respond to it. You can configure your quality of service as you like. Give preference to the most important applications. They have a really intelligent data compression and deduplication and application optimization, which reduces bandwidth usage by dozens of percentages. I don't know the exact number from the top of my mind, but they have, for example, an intelligent two-way handshake in which they can go and sit in the middle, which really increases the speed of the way which sessions are set up, and also they do some really great stuff on bandwidth management. And everything's encrypted, and especially compared to MPLS, it's very cost effective. And also quite a young company born in the cloud era, so connecting to not only Azure or AWS, but also Salesforce, for example. They offer that tight integration. So to summarize my presentation today, those are my key takeaways. We see public cloud exploding within enterprises. More and more workloads are migrated. A lot of new companies that are starting in the cloud, they're not even looking at a private cloud or any other data center solution because of that speed of development or that worldwide presence. But also within existing customers, we see a lot more accounts, subscriptions, VPCs, VNets. So those environments are really, really growing. And you need to manage that. You need to keep it secure, and for that you need the knowledge. But in some cases, you just need additional tooling, additional solutions. The cloud service provider have some great native networking solutions, like Direct Connect, like ExpressRoute, like the Transit Gateway. But you do have to be aware of the limitations. Those limitations are being taken away also, of course. They're also continuously being developed. Limitations are, for example, number of routes advertised is being increased, but you really have to keep an eye on that, and also the difference between those cloud service providers. If you are forced, sometimes you're just forced to manage a multi-cloud environment, you really need to be aware of those differences. And again, multi-cloud, you're single cloud until you're not. You better prepare for becoming multi-cloud and know which way you're going if this situation occurs to you. And on the Aviatrix part, if you really need that additional insight or multi-cloud management, or for example, from a disaster recovery point of view, you need to be able to move workloads between those public cloud providers. Such an overlay solution can be of really good value to you. Recently, Heineken decided to start using Aviatrix within their public cloud. So I'm not saying it's the best beer in the world, but I think this is a sound solution, sound decision. And as a final one, if you're using traditional WAN, MPLS, or IPsec VPN tunnels a lot, and you do have your major workloads running in a public cloud, really take a good look at SD-WAN, as it will offer you some really great advantages. Right, that was my last slide. Let me see what are is there any additional questions popping up? Tristan Anthony is, well, he's quite enthusiastic. With respect to Azure, do you find those deployments more focused on moving traditional on-prem Active Directory infrastructure services to the cloud? Or more broad than this, I do see a lot of integration with Active Directory. That's definitely one of the use cases customers choose Azure over one of the other providers. If they are heavily into Microsoft 365, for example, or need that authentication, authorization, single sign-on on any of those services, that's one of the major reasons they choose Azure, definitely. Your experience, observation, what are the primary drivers for multi-cloud deployment? Yeah, portable Kubernetes workloads play a central role in multi-cloud deployment strategies. I do not see, like I said, that is one of the use cases I see customers sometimes choosing multiple cloud providers. I see two major reasons they do it. One is, like I said, they choose their cloud on its strengths, the stronger services they want to start using. I mentioned those examples earlier. The other one is that they they choose for avoiding vendor lock-in. I don't see that as a really legitimate reason, but there are customers that think of it that way. We just do not want to be involved with just one cloud provider, so we start deploying at least two. So yeah, those are the most important ones. Robert van der Stadde asks, how does Aviatrix integrate with external monitoring tools? Well, it has a really good integration with Splunk, Datadog, for example. So, and I believe a few more. I can't remember all of them, but those, yeah, those are a couple of external monitoring tools you can attach the Copilot on, for example, for some additional analytics. So that's what I had to tell to you. Well, it's exactly 2 o'clock. Kelly, if there's no more questions.
Yeah, we're right on time. I think yeah, thank you, Mark, for the presentation. I think there were quite some questions, which is always great. If anyone else has any questions left for Mark, which maybe take a bit longer, or anything else you would like to know, please leave them also in the chat box so that we can share them with Mark, and that you can get your answer. The last thing I have to say is that in the chat box for the participants, you will also find a questionnaire, which is just a quick questionnaire for quality improvement. So it would be great for us if you could fill that out. Yeah, and thank you all for joining, and thank you, Mark.
Yeah, thanks everyone for joining and the interaction. I really love that. Please reach out to me through LinkedIn or email mark.norman@cloudnation.nl if you have any questions or remarks or would like some more information.
Thank you so much, everyone.
Okay.
Have a good day.
Goodbye.